Okay, just heads up, take a look at the actual list of questions. There's a question that's not on the mock test about gravitational potential and why they're negative. So just look that up, right? Okay, so label on the potential diagram above where there's no net gravitational field between the planet and the moon. Well, let me tell you. Okay, remember that, what is it? Isn't there a formula that just says this? Right, this literally is the slope of the gravitational field is the slope of the potential, right? So if the slope is zero, that's slope, right? If the slope is zero, then the gravity is zero, right? So somewhere between here and here, there's a zero slope. So just mark that spot, okay? The zero slope. Yeah, it's pretty obvious. Anyway, okay, so calculate the distance from the center of the planet to the point where there's no net gravitational field. This is a tricky little problem, right? So ultimately you've got G is equal to GM over R squared, right? And that is actually in the data packet. The fact that electric field is KQ over R squared is not, but this one is in there, right? Okay, and what you do is you just set these guys equal, right? So GMA, and then let's call this spot X, right? And call this distance X, right? And then let's call the distance separating their centers, we'll call that L, right? So the total distance from here to here is L. Let's call the distance to the spot of zero gravitational field X. This distance is, of course, L minus X, right? Right, and this gets a little bit tricky, right? So what we're going to say is that the gravitational field toward this planet A, right, over X squared, right, is going to equal G mass of B over L minus X squared, okay? Now, let me suggest a strategy here, okay? Obviously, you can cancel G, right, okay? And then let's get, let's do this. Let's go, I'm going to do L minus X squared over X squared, right, equals, right? I'm just cross multiplying. The beautiful thing about this is that we can now square root both sides. This side just becomes the square root of the ratio of the masses. This side, the squares go away, right? And then, of course, you can rewrite this L over X minus X over X, right, is the square root of MB over MA. Just a mathematical trick, right? I think I got to this point. I was like, oh, it is impossible to solve for this, right? Okay. Of course, this is L over X minus 1, and then we have just one X there, okay? Just let me suggest that you do it that way, okay? And then C says, calculate the total gravitational potential at the surface of the moon due to the planet and the moon, right? So find the potential right there. Remember that the potential is going to be at the surface is going to be minus GMA over RA, right? And RA is going to be this distance here, right? So you got to figure that out from this data, right? I think it's going to be what the distance separating their centers minus what the radius of the moon or something, right? Okay. And then it's going to be plus minus G mass of the moon, right, over RB, right? Well, that radius B is just this, right? Okay. All right. Happy hunting. Oh, and then notice, read the. My suggestion is read the what actually is on the test, because there's another question down here that's not on the mock test about drawing this graph. Okay. That's a pretty good hint. All right.